Hello students, welcome to this class of vectors in which I will be teaching you uh, types of vectors. I'll be teaching you about the definition of vectors in this particular lecture, and later on we will discuss all the rules of vectors and how to add them, subtract them and take a product. So in this lecture we will be mainly dealing about vectors definition and some of its types. So let's start with what is a vector. A vector is a physical quantity just like mass, length, time, but the only difference is that the vector has direction along with its magnitude. So a vector is a physical quantity which has magnitude as well as direction, and it should satisfy the rules of vector addition. Now let us understand these terms one by one. What is magnitude? Magnitude is the size of any physical quantity. Let's say it is 10 kgs, right? So the size is 10, right? And if I say 1 gram, the size is 1 gram. This is known as the magnitude of that physical quantity. And here the physical quantity is mass, which are measuring in kgs and grams, right? So mass doesn't have any direction. So such quantities are known as scalars. And we know how to add them. 10 kg plus 2 kgs. We simply add them and we get 12 kgs, right? But that's not the case with vectors. Vectors have to be added in a different way. For example, let's say this is a bottle, and if you push 10 newtons here and 2 newtons in the opposite direction, will it make 12? 10 and 2 added together will be 12? No. Obviously these forces are opposing, so the final result would be 10 minus 2, which is 8 newtons. Now if the same forces are kept in a different orientation, suppose they are applied on the same side. So if this is the bottle and you apply force 10 newtons and 2 newtons in the same direction, then the result becomes different, which is 10 plus 2 is 12 newton. So that is why we say that force follows a different set of rules, and we will see that these different set of rules in upcoming lectures, right? So my point of explanation here is to tell you that vectors do not follow the normal rules of addition and subtraction. That is why we have to construct a different set of rules, and those rules we will be discussing in the upcoming lectures. Okay, now let us now see how we can represent a vector. So a vector is represented by an arrow. This arrow has a tail, which is A, and a head, which is B. And we can name this vector and we can symbolically represent as AB with a vector sign, right? So this is a representation of a vector. Now some of you might like to use a single letter, not AB but just a single letter, let's say P. So that is also fine. You can go ahead with both of the ways of writing vectors, right? So if P is a vector, it has two characteristics. One is called magnitude and the other is called direction, right? Now if I say this is a vector AB representing, let's say 10 newtons, right? So if I ask you what is the magnitude, you will say yes, 10 newtons, and this magnitude is represented with P vector with a mod sign. This means that we are emphasizing only on magnitude and not on direction. Also we can simply write P without the vector sign. That also means we are emphasizing magnitude and it has no information of direction here. Now direction is from A to B. There are other ways of writing direction also, which we will be learning later on. So we have discussed simply that if P is a vector, its magnitude can be written with a mod sign and its direction can be emphasized with just simply saying that A to B or maybe if there is north, east, west, south, we can specify in those terms as well. So this is how we represent a vector. Now I'm going to tell you a very interesting aspect of vectors. There are some exceptions to the rule, like some of the quantities have direction but they do not come under the category of vectors. For example, let's say current. Now if there is 10 amperes current going in here, it goes into two parts, 2 newtons here and 8 newtons here. So you see the 10 newton divides itself into 2 and 8, right? Okay. Now if you add 2 and 8, you will get 10 amperes. I'm sorry, not newtons, amperes. So 2 amperes and 8 amperes gives you 10 amperes, right? So if I take another example, 2 ampere with 10 ampere, if you add them, you will get 12 amperes. Now is this simple addition? Yes, 10 plus 2 is 12 is simple addition. So current is following a different set of rules. It is following the rules of scalar addition. 10 plus 2 are added like scalars to give you 12 ampere. That is why it is not following the rules of vector addition. It is only following the rules of scalar addition. That is why current will come under the category of scalars, even though current has direction, right? It will come under the category of scalars. Thank you.